Heyo. Okay, this is the last AP chemistry topic that I would cover with you guys. This is dealing with electron spectroscopy, and I have been telling you about that for so long. Now, where can you find the notes for this? Go into the bulletin board that you're seeing there. Go to downloads. You'll see electron spectroscopy unit. Click on that. It is a PowerPoint, and I'm going to go over that with you guys very briefly. Okay. Now, I also uploaded the notes for the Nernst equation for solving delta G and your E in a non-1 molar solution for the last chapter dealing with electrochemistry as well. But I want to focus on electron spectroscopy. I've been telling that to you guys all year long. And I call this Chapter X because I didn't know what chapter to put it on. Okay, oops, hang on. Okay, so let's click. Okay, so electron spectroscopy. So what is it exactly? It's a technique that we can study electronic structure and its dynamics in atoms and molecules. So in other words, we're looking at atomic structure. Frank, remember about electrons hanging around the nucleus of the atom, that there are different energy levels, and then inside of those energy levels you have the energy sublevels, okay, and each of those sublevels, they have their orbital regions, okay, like 1s, 2s, 2p, okay, and if you think about 2p, think about 2p in the x direction, 2p in the y direction, 2p in the z direction, just to give you a review on that. Now, how is this process of spectroscopy done? Well, the idea is that there's some kind of an energy source, okay, an excitation source, like X-rays, electrons, or synchrotron radiation, and the idea is it will eject the electron from the inner shell orbital of an atom to somewhere outside of that level. So you kind of have a rough picture there of what in the world is going on. So you get this photon, this packet of energy, if you will. It hits the electron, and the electron jumps. Okay, it jumps a level, maybe 2 levels, depending on how much energy it was given. Now, how do we detect the electrons moving up or down? Well, there's a couple of ways. One way, we can put the radiation in, and we can observe the absorbance of the electron. Now, how do we look at that? How do we see that? If you look on the left here, you'll notice you got your delta E, your energy. LUMO and HOMO, I'm not going to worry about that. That doesn't matter. Now look at the arrows going up and down. Remember, that's about the electrons spinning opposite of each other. Okay, now you put radiation in. Now you got electrons that are absorbing the energy. Now it's jumping to a higher level, which is what we are seeing here. Okay, now what if the electron is now done with it and now it's coming down? Well, when it's coming down, that's when you get your fluorescence. It's giving off the radiation, whatever form of radiation it could be, and that's when we detect it. So that's how we detect it. Now, we can look at X-ray photoelectron spectroscopy or electron spectroscopy for chemical analysis. Okay? Detecting electrons that are ejected from higher orbitals to conserve energy during electron transitions. This is another one, Auger electron spectroscopy. So those are the 3 basic ideas how we can detect. Not important for the AP exam. This is the important stuff. Now, what is it that these graphs look like for the AP exam? Look at the graph on the left, and you'll notice that you have the number of photoelectrons starting from basically a low number to a high number. If you look on your x-axis, okay, you have your ionization energy on the left-hand side from low, working your way up. Now, if you look at the lines on the graph for this photoelectron spectrum, you notice that you have here, you got these spikes. Now, what's interesting enough about this is, if you were to go and turn this 90 degrees, like we're seeing here, it seems to match up an electron energy level diagram. So that says something about the spikes. Now, the height of the spikes would have to do with how many electrons are spotted in that region. The energy, remember, all the electrons have energy of some form or another and some level of it. And that would explain the different energy levels that we have, like level 1, level 2, level 3, and so forth. So those spikes are matching, they're corresponding with the electron energy levels that we're seeing. Okay, I'm going to go over to here. Now we got to look at how does that look? How does that look for our, I'm moving my picture here. How does that look for our spikes here? So let's take a look at helium for a moment. Helium is up here on the top. And they're not going to ask you, how many joules or, what's the number of electrons. What you got to pay attention to is look at the spike, and it's connected to helium. Okay, so what is that spike representing? It's representing 1s. Because remember how helium, it's a small atom, right? It's bigger than a hydrogen, but definitely smaller than lithium. But it's 1s. That spike represents the 1s orbital / level. Okay? Level 1, sublevel s. That is what that spike represents on the helium. Okay? Because remember, helium has a maximum of 2 electrons. Now let's look at the second one here. Now the second one is neon. Now how many electrons does neon have? Remember, it is a noble gas, so it's not very reactive, but you do notice that, hey, if you look on the periodic chart, which you guys are allowed to, neon has got 10 electrons. Now notice you've got 3 spikes going there. So wait a minute, each of those spikes represents an energy level and a sublevel to go with that energy level. Okay, so let's look at it. So for neon, you've got 1s, that's the first spike. The second spike is 2s. The third spike is 3s. Now, how many electrons go in 1s? 2. How many electrons go in 2s? 2. Okay, so then you look at the last one, the 2p. How many electrons fit in that total? 6. 2, 4 with plus 6 is 10 electrons. This matches neon perfectly. So what we're seeing there as our spike, this is what we are seeing with neon. We expect this. Okay? So those spikes represent 1s, 2s, and then if further along to the right, 2p. Now, let's look at the krypton down below. So we have krypton, and you may notice that they've shortened the lines a little bit because those spikes actually would be spread further apart. So again, krypton has, I think, let me take a quick look here. Oh, hey, 36 electrons. So we can look at 1s for the first spike, 2s for the second spike, 3s for the third spike. The fourth spike is 3p. Then you have 4s, okay, because remember, then it goes to 3d here for spike number 6. Then you're going to go to 4p, and then you go on to 5s. I believe it's 5s. Well, close enough. Okay, so those spikes, bottom line, those spikes represent the energy level and the sublevel in the energy level. Okay, that's what they're asking you. Now, what kind of a question could they ask for something like this? They could give you a spiky diagram like this, and they may ask you, hey, what element does this represent? Okay, and then this is going to be, I would say, more of a multiple choice type question as opposed to an FRQ type question. Okay, I think we already talked about what do the spikes in the graphs mean. Think 1s, 2s, 2p, 3s, 3p, 4s, 3d. Okay, now, last thing, tutorial that I would recommend you guys to look up. Okay, there is a video that you can look at this. They can give you some more information. But anyways, guys, that's it. That's it for our last unit together. And I'm signing off.